Factoring in general is the most convenient and useful method for solving a quadratic equation. Let's go ahead and look at this. Given the following quadratic equation, ax squared plus bx plus c is equal to 0, we can go ahead and make a few assumptions. The first one is that we can divide both sides by a, and we'll get a quadratic of the following form: x squared plus b divided by ax plus c divided by a is equal to 0. What we did here is we made the leading coefficient in this quadratic equation equal to 1. And we can go ahead and rewrite our second coefficient here, b divided by a, as b prime, and we can rewrite c divided by a as c prime. Which means we can assume our quadratic equations are of the form x squared plus b prime x plus c prime is equal to 0. By abuse of notation, that means we can always think of these quadratic equations as having a leading coefficient of 1. Let's go ahead and start a new page using this assumption. Given our polynomial x squared plus bx plus c, what we want to do is we want to rewrite this as a multiplication of two linear terms, x plus, we'll call it e, times x plus f. If we write the right-hand side out, multiplying it, we'll get that the right-hand side is going to be x squared plus fx plus ex plus ef. Rewriting this, we get that x squared plus f plus e times x plus e times f. Now, if we look carefully, we have a few different equalities that will tell us how to factor this quadratic equation. Here we see that our b has to be equal to the sum of our f and our e, and our c term is going to be the multiplication of our e and our f. This will put enough constraints on our quadratic equation to solve it. Let's look at an example. Example 2. Factor and solve the following equations. In part A, we want to solve x squared minus 5x minus 6 is equal to 0. Looking at this term, we have two options here. We have 1 times 6, or we'll have a 3 and a 2. Since we have a negative sign in front of this 6 here, this is telling us that our linear terms will have one positive and we'll have one that's negative. Finally, we want the sum of our e plus f to be equal to a negative 5. Out of the green numbers, the only combination that will allow this to be true is when e is equal to 1 and when f is equal to 6. So to factor this quadratic formula, this will be given by x plus 1 times x minus 6, which is equal to 0. So the solution to this quadratic equation will be x is either equal to a negative 1 or x is equal to 6. In the next equation, we're giving the quadratic equation x squared minus 4x minus 21 is equal to 0. 21 is the multiplication of 3 and 7, or it's also the multiplication of 1 and 21. In front of our 21, we have a negative sign, which means this is going to be factored out to be an x plus some number times an x minus some number here. Then we need the sum of our numbers, d and e, to be equal to negative 4. Well, this is only going to occur when d is equal to 3 and e is equal to 7. This means that we can factor our polynomial as x plus 3 times x minus 7. The solution to this quadratic equation then is x is equal to a negative 3 and x is equal to 7. In the next part, we're given the quadratic formula x squared minus 16 is equal to 0. Notice we could solve this one using the square root property, but let's go ahead and factor this. We know 16 is 4 times 4, or 1 times 16. And since we have a negative sign here, this is going to factor out to be an x minus some number times an x plus some number. And we need these numbers, negative e plus f, to be equal to 0, since our quadratic equation doesn't contain a term b times x. The only time this is going to be equal to 0 is when we have negative e is equal to 4, and when we have f is equal to 4. This means our equation is going to factor out to be an x minus 4 times an x plus 4, which is equal to 0. The solution to this quadratic equation then is x is equal to a plus or minus 4. Let's go ahead and look at one more factoring problem, part D. This time we're giving x cubed plus 11x squared plus 10x is equal to 0. We notice first that this is not a quadratic equation because the highest power is given by a cubed. But we can pull out an x from each term and make it quadratic. Here we'll have x times x squared plus 11x plus 10 is equal to 0. Now we can go ahead and solve this inner term here. Solving this inner term using factoring, again, we have 10 is either the product of 10 times 1, or equivalently, it's also the product of 5 times 2. Now, since we have a positive sign here, we have two options. Either our quadratic equation is going to factor be an x minus e times an x minus f, or it's going to factor to be an x plus e times an x plus f. To determine which one it's going to be, we just need to look at this term here. Here we need our e plus f to be equal to 11. This is only going to happen when we have e is equal to a positive 10 and f is equal to 1. Which means that we want to choose the second option here. Then our quadratic equation is going to factor to be an x times an x plus 10 times an x plus 1. Therefore, the solution to this quadratic equation is going to be given by x is equal to 0, x is equal to a negative 10, or x is equal to a negative 1.